Okay, so in this lesson we're going to talk about an important topic called the discriminant. And the discriminant allows you to determine the number of solutions and the type of solutions of a quadratic equation. So even before solving the equation, you can actually determine how many solutions you will get and what kind you will get. Now, it's not going to tell you what the solutions are, but it does tell you the number of solutions and the type of solutions that you will end up with. So then you may ask, well, what is the discriminant? Well, remember when you solve quadratic equations, and so when you had this quadratic equation, ax squared plus bx plus c equals 0. Now remember, when you solve these quadratic equations, you were reminded that a, b, and c are real numbers, so that's important. So they're real numbers. And you were also told that a could not be 0. So a could be any real number, but a could not be 0. And remember, the reason for that is because if a is 0, you're left with a linear equation instead of a quadratic. Okay, so then remember, when you solve these quadratic equations, one way you could solve these is using the quadratic formula. So when you look at the quadratic formula, remember it's negative b, so the opposite of b, plus or minus the square root of b squared minus 4ac, all of that divided by 2a. And so it turns out that the discriminant is this expression that's in the radicand, this right here. So the discriminant is b squared minus 4ac. That's the discriminant. Okay, so that expression will allow you to determine the number of solutions and the type of solutions you're going to end up with. Okay, so I know that in previous lessons you solved quadratic equations using the quadratic formula, but in order for us to use or to understand how the discriminant applies to this idea here, let's continue doing some more examples using the quadratic formula. Okay, and then we'll come back and we'll look at specific examples where you're just told to find the discriminant. Okay, so this will be a review for the most part. So some of this will be a review, some of this will not. But this part is necessary to understand this part here. Okay? All right, so number one, let's suppose you want to solve this quadratic equation. All right, so solve this equation. So number one, let's suppose we had 2x squared plus 7x equal 15. Okay? Now remember, when solving a quadratic equation using the quadratic formula, it has to be in standard form. All right, so this is not quite in standard form, so I've got to bring the term 15 to the left-hand side. And so in standard form, I get this. Now you may remember, it was also a good idea to label A, which is 2, B, which is 7, and C, which is negative 15. And then what you did was you substituted all of this into the formula. Okay, so when you did that, you had x equal the opposite of b. Well, the opposite of 7 is a negative 7, plus or minus the square root of, in parentheses, remember we said b, which is 7 squared, minus 4 times a is 2, times c, which is negative 15, all divided by 2 times a, which is 2. And so you ended up with negative 7. When you simplify this, remember, the next step, was to simplify the radicand as much as you can at this step. So 7 squared is 49. And then you said a negative 4 times 2 times a negative 15. So when using a calculator, that gave you, that gave you 120. So this would be plus 120, because a negative times a positive times a negative is a positive. All divided by 4, and so this became negative 7 plus or minus the square root of 169 divided by 4. And at that point, if you recall, we asked ourselves, is 169 a perfect square? Because if it is, you want to simplify this. And so the square root of 169, so 169 is a perfect square. And the square root of 169, if you don't know by by um, by chance, it's 13. So we get negative 7 plus or minus 13 divided by 4. And then at that point, remember what happened. At that point, this is where you broke this down into two separate solutions, because this was rational. Remember, when the square root no longer appears, when the radicand is a perfect square, we end up with an integer, with a whole number, and so the square root's no longer there. So that's where we ended up with rational solutions. Okay, so we did have that discussion in previous lessons, and so what we did was we broke this down. So we said this becomes negative 7 plus 13 divided by 4, and then negative 7 minus 13 divided by 4. And so negative 7 plus 13 is 6, so this became 3/2, and then negative 7 and a negative 13 is a negative 24, which equals a negative 5. So those are your two solutions, and notice those are rational numbers. Okay? Now here's the important thing. In the past, when we solved this using quadratic formula, we referred to this as a radicand, but you now know that this value 169 is a discriminant. So 169 is a discriminant. So in this problem right here, the discriminant is 169. Okay? So now be careful, it's not the square root of 169. Some students mess that up and they think it's the square root. It's not. It's only b squared minus 4ac. That's your discriminant. But here's the important thing I want you to get out of this. So the discriminant is 169. In our discussion, we said 169 was a perfect square. So the discriminant is 169, which is a perfect square. Okay, so that's a perfect square. And notice that when we had this perfect square, we ended up with two different rational solutions. So we had two different rational solutions. Okay? So if the discriminant is a perfect square, you're going to end up with two different rational solutions. Okay, now here's a little chart we're going to complete as we go through this. Okay, so b squared minus 4ac. So b squared minus 4ac is a perfect square. Okay? So if it's a perfect square, example like 169, we're going to end up with we'll leave this off for a while. We're going to end up with number solutions will be two distinct or two different. So two distinct, two different, and these are rational solutions. Okay, so rational solutions. All right. Now, another way you may see it written out is this. So you may also hear the phrase, if the discriminant is a perfect square, you're going to end up with two real solutions. So remember, a real number is rational or irrational. All right. So since the discriminant is positive, which is positive. Okay, so since it's positive, you're going to end up with two real solutions, and since it's a perfect square, you're actually going to end up with two different rational solutions. Okay, now another phrase you may hear is this: two unequal real solutions. Two unequal real solutions. And I guess I should have put this right here, two different real solutions. So these are all different things you can see about a perfect square, a discriminant that's a perfect square. So if it's a perfect square, you're going to end up with two different or two distinct rational solutions. Okay. Now, since it's positive as well, you can also say it's two different real solutions or two unequal real solutions. Okay. All right. So that's what we get if the discriminant is a perfect square. So if it's a perfect square, it's definitely going to be two rational solutions. Since it's positive, it's going to be real solutions. But a rational number is real. Remember, a real number is either rational or irrational. Okay? But since it's a perfect square, it's rational. All right, let's look at the next example. All right, so let's look at this one. So this will be number 2. So let's suppose in number 2, I have this in number 2. So let's suppose number 2 is this. We have 9x squared minus 6x plus 1 equals 0. Okay, so 9x squared minus 6x plus 1 equals 0. So let's just go ahead and actually solve this equation. So let's solve it. So if I solve this equation, so A is 9, B is negative 6, and C is 1. Okay? So if I solve this equation, I get x equal the opposite of negative 6, which is 6, plus or minus the square root of b squared, so negative 6 squared in parentheses, minus 4 times a, which is 9, times c, which is 1, all divided by 2 times 9. So that becomes 6 plus or minus the square root of negative 6 squared is 36. A negative 4 times 9 times 1 is 36, so that's 36 minus 36 divided by 18. So I get 6 plus or minus the square root of 0. Now remember, the square root of 0 is 0. So this becomes 6 divided by 18, which is 1/3. So the point's this. The square root of 0 is 0, so 6 plus 0, 6 minus 0 is 6, right? So notice what happens. Now remember, 0 is the discriminant. So the discriminant is 0. Okay? The discriminant is 0. So the discriminant is 0. You're only going to end up with one rational solution. You will get one rational solution. Okay, so you get one rational solution. Now, this rational solution, you can also say that this 1/3, and I'm going to go ahead and say this right now so you can understand what my next phrase will be. I could have solved this equation instead of using a quadratic formula. I could have solved this by factoring, but the reason I used a quadratic formula was so you can see the discriminant. So if I factor this, here's what you get. You're going to get 3x minus 1 times 3x minus 1, which equals 0. And remember, notice that those two factors are the same. So remember when we solved a quadratic equation where the two factors were the same, we just used one of them. So what I want you to notice, though, is that if I set both of them equal to 0, I want you to see what happens. So it's the same expression, the same equation, right? So I get 3x equal 1, x is 1/3. Same thing here, 3x equal 1, x is 1/3. So notice that 1/3 occurred how many times? 1/3 occurred twice. So sometimes you'll hear this phrase, if the discriminant is 0, you will get one rational solution, which is a double solution. So in other words, it occurred twice. All right, so if the discriminant is 0, you're going to get one rational solution. Another phrase you can hear is that it's also a double solution. It occurred twice. Okay? All right, so let's fill this part out now. So if the discriminant is 0, okay, example will be 0. So I'm going to leave this part out for right now. I'm going to come back to it. You're going to end up with one rational, let me put that here, one rational solution. So you end up with one rational solution. Okay? Another thing you can hear is this. You're going to end up with one real solution. You'll agree that this is a real number, right? Okay. So you get one real solution. Something else you may see for that one is this. You're going to get a double root. Double root. You may hear that phrase, a double root. You may hear the phrase one repeated real solution. One repeated real solution. You may hear the phrase one rational solution. One rational solution, which this is supposed to be rational, which may also be with the phrase double root. Double root. Remember, root means the same thing as solution. Okay, so here's the point I want to make between these two. Okay, listen carefully. If the discriminant is positive or 0, if the discriminant is positive or 0, your solutions are real. Okay, notice the solutions are real numbers. Okay? If the discriminant is positive and a perfect square, you're definitely going to get 2 rational solutions. They're going to be rational. If the discriminant is 0, it's going to be rational as well. So if it's a perfect square or 0, you get rational solutions. Perfect square or 0, you get rational solutions. Kind of makes sense because when we did this, remember A, B, and C are real numbers, so a real number divided by a real number is still a real number. And A, B, and C in our case were integers, and so an integer divided by an integer is going to be a rational number. Okay, so all right, so since if it's positive or 0, you're going to get real solutions. If it's positive, you get 2 real solutions. If it's 0, you only get 1. Okay? Now, it's called a double root, though, because if you were to factor and said each one equals 0, it would occur twice as a solution. But we only list it once. All right, let's look at the next example. Okay, number 3. So let's suppose in number 3, I have x squared minus 3x minus 5 equals 0. So x squared minus 3x minus 5 equals 0. So let's solve this using quadratic formula. So a is 1, b is negative 3, and c is negative 5. And so if I substitute back into the quadratic formula, I get x equal the opposite of b, which is 3, plus or minus the square root of negative 3 squared, minus 4 times a, which is 1, times c, which is negative 5, all divided by 2 times a, which is 1. And so then this becomes 3 plus or minus the square root of, remember this is the discriminant, so when I do this I get 9 plus 20 divided by 2, so that becomes 3 plus or minus the square root of 29 divided by 2. Alright, now remember, one of the things we asked ourselves when we solved this was, is 29 a perfect square? No, 29 is not a perfect square. All right. And then one of the things you did also in the past was you simplified this square root, but that's not the point here. Here's the point. I want you to notice that 29 is not a perfect square, and so remember, if it's not a perfect square, this is not rational, it is irrational. So these are irrational solutions. Irrational solutions. Okay? Now, remember we broke this down into 2 parts. You can also write this down to 2 parts as 3 plus the square root of 29 divided by 2, and then 3 minus the square root of 29 divided by 2. All right, and notice those are two different irrational solutions. Okay? So here's the point. The discriminant is positive and not a perfect square. Okay, so the discriminant, which is 29, is 29, okay, which is positive and not a perfect square. Okay, so what that means is this. Look at what you have. So what that means is this. If the discriminant is positive, but not a perfect square, okay, so positive and not a perfect square, you're going to end up, how many solutions did you have? 2. You're going to have two different irrational solutions. 2 different irrational solutions. Okay? 2 different irrational solutions. Now remember, we said this earlier as well. If the discriminant is positive, you're going to end up with 2 different real solutions also, right? And different, unequal mean the same thing. So 2 different real solutions. So I can say the same thing here. I will also get 2 different real solutions. Okay, so 2 different real solutions. The other thing you could, let me make sure I have this. So we said 2 different distinct irrational solutions, 2 different real solutions. All right, so remember the other word could be unequal. Remember, different means unequal. Okay? All right. So far we have this. If the discriminant is positive, or 0, you get real solutions. Okay? If the discriminant is a perfect square, they are rational. If the discriminant is not a perfect square, it is irrational. All right? Okay, now let's look at the next one. All right, suppose we had number 4. So number 4, let's suppose we had x squared minus 3x plus 5 equals 0. X squared minus 3x plus 5 equals 0. So a is 1, b is negative 3, c is 5. And so if I substitute that back into the quadratic formula, I get x equals the opposite of b, so that's 3, plus or minus the square root of negative 3 squared, minus 4 times a, which is 1, times c, which is 5, all divided by 2 times a, which is 1. So then I get 3 plus or minus the square root of 3 squared, negative 3 squared is 9. A negative 4 times 1 times 5 is a negative 20, all divided by 2. So this becomes 3 plus or minus the square root of, now remember 9 minus 20 is a negative 11 divided by 2. And remember, you're taking the square root of a negative number. Now remember, the square root of a negative number is not a real number. Remember, that's an imaginary number. That's an imaginary number. And so the way we wrote this was like this: 3 plus or minus I square root of 11 divided by 2. All right, so we end up with, if you think about it, 3 plus I square root of 11 divided by 2, and then 3 minus I square root of 11 divided by 2. So if the discriminant, and remember, notice the discriminant is negative, right? So the discriminant is negative. All right, in this case it's negative 11. So if the discriminant is negative 11, you get 2 different distinct, another word for different is distinct, 2 different distinct imaginary solutions. Okay, imaginary solutions. Now remember, this is not a those are not real solutions. So if the discriminant is negative, you don't get real solutions, you get imaginary solutions. All right, so let's summarize this for number 4. All right, so if the discriminant is negative, for example, let's say the discriminant is negative 11, okay? We're going to get 2 different imaginary solutions. 2 different imaginary solutions. All right, you can also say you're going to get 2 solutions, 2 distinct or 2 different two distinct, two different non-real solutions. So that's something else that you may see. So if the discriminant is negative, you may see the phrase that you end up with two distinct or two different non-real solutions, but you know they're going to be imaginary, right? All right, but you may see non-real. So non-real means that you're not going to get real solutions. All right. So another phrase for this two distinct non-real is that you're going to get zero real solutions. So let's just know that. So two distinct non-real solutions means that none are real. So zero real solutions. So you get two distinct imaginary solutions. Remember, those are not real solutions. So non-real solutions. You could see this phrase, two distinct or different. Two distinct or different. Now listen carefully to this. Two distinct or different non-real complex solutions. Two non-real complex solutions. Now let's talk about this. Do you remember in the previous lesson, or probably not the previous one, but maybe two before this one, we talked about complex numbers? Okay, so remember, a complex number is a real number and an imaginary number. So a complex number can be real or imaginary. What this is saying is that this complex number right here, is not real. That's all that's saying. All right, so this complex number, that's a complex number. All these are complex numbers, but that's a real complex number. This is a non-real complex number. So you may see this. All right. So non-real complex number just means, all that does is just means that the solutions are imaginary. That's all that means. Imaginary. Okay? All right. Okay, now, so one of the things I wanted to mention about this, you remember when we did number 2, I think it was? So let me go back to number 2. When we did number 2, we had that the discriminant was 0, and we factored. So here's the point I want to make. So one of the things you can also do with the discriminant is determine if your quadratic equation can be factored. And so if it's 0, the quadratic equation is factorable. Quadratic equation is factorable. Okay? If it's a perfect square, it's also factorable. So quadratic equation is factorable. And when I say factorable, I want you to understand that that's factorable over the integers. Over the integers. Okay, meaning this, when I factored this, notice that 3 is an integer, negative 1's an integer, 3 is an integer, negative 1's an integer. That's what that means. Okay? If it's positive but not a perfect square, then it's not factorable over the integers. Not factorable over the integers. All right? And then negative 11 is not factorable over the integers. All right, so that's the point I want to make there. Remember, a positive number is not a perfect square. It would be something like 29. Okay? All right, so now let's quickly review what we have here. Let me go ahead and make that a little bit smaller. So this is going to be very important for you to look at. So what's important is this. So the discriminant, remember, is b squared minus 4ac. So this is what we learned. If it's a perfect square, you're going to get two different rational solutions. Okay? If it's 0, you're going to get one rational solution. If it's a positive number but not a perfect square is going to be irrational. So you're going to get two irrational solutions, different irrational solutions. Okay? So keep in mind, if your discriminant is positive, you're going to, or 0, you're going to get real solutions. Okay? The only time you get imaginary solutions is if the discriminant is negative. If it's a perfect square, though, they're rational. If it's 0, you get 1 rational. If it's not a perfect square but still positive, it's irrational. All right, and then just know that these phrases, so you may see the phrase that if it's negative, the discriminant is negative, you're going to end up with two distinct or two different non-real complex solutions. And all that means is that they're imaginary. That's all that means. Okay? All right, so let's just quickly do a couple examples where you don't actually solve the equation, you just look at the discriminant. All right, so let's look at this idea. Okay, so the problems will say something like this: find the discriminant or evaluate the discriminant and determine the nature of the solutions. Now, by nature, we're just asking how many solutions and what kind. That's all they're asking. Okay, so you got to remember, if you're gonna use a discriminant to determine the nature of the solutions, all you need is the discriminant. So remember, the discriminant is b squared minus 4ac. That's all you need to evaluate. All right. So it helps though if you label a, b, and c. So a is 2, b is -1, -5 rather, c is 1. Okay. So remember though, you got to be careful. Make sure a is the coefficient of x squared, b is the coefficient of x, and c is your constant, and it must be in standard form. All right, so let's substitute this into the discriminant. So we get b squared, so we get -5 squared minus 4 times a, which is 2, times c, which is 1. So I get 25 minus 8, and 25 minus 8 is 17. All right, so the discriminant is 17. So what kind of number is that? That's a positive number, definitely, right? But is it a perfect square or not a perfect square? So that's what you got to ask yourself. So we know it's positive. So the question is it a perfect square or not a perfect square? All right, so it's not a perfect square. So we're going to say this then. So since the discriminant is positive and not a perfect square, we will have two different irrational solutions. Okay, two different irrational solutions. You may also see this though, which also means two different real solutions. All right, so irrational solutions are real, but it is very important you understand that since this is a positive number and not a perfect square, they're going to be irrational. All right, if it's a positive number and a perfect square, it's rational. All right, so that's important to understand. Okay, let's look at number 2. Number 2, and we're done. That's all you have to do. Notice I didn't solve it. I just used a discriminant to kind of help me to understand what kind of solutions you end up with without even actually having to solve it. Okay, so number 2, let's suppose we had this. Let's suppose we had 4x squared equal 12x minus 9. All right, so let's suppose we had this quadratic equation. So without actually solving the equation, you want to evaluate the discriminant to determine the number of solutions and the type of solutions. Well, what do you notice about this quadratic equation? First of all, it's not in standard form, so we got to put this in standard form. So in standard form, I get this. Okay? Now, before you use the discriminant, remember the discriminant is b squared minus 4ac. Before you use the discriminant, let's determine a. A is a coefficient of x squared, which is 4. B is a coefficient of x, which is -12. And c is your constant, which is 9. And so we're going to take these values and substitute into the formula. So I get equals. b, which is negative 12, I'm squaring that, minus 4 times a, which is 4, times c, which is 9. Okay, so I get negative 12 squared is 144. All right, a negative 4, use your calculator if you need to. A negative 4 times 4 is 16, and then 16 times 9 is 144. So what do you notice about this discriminant? Is what kind of number? Well, it's 0. So if the discriminant is 0, what that means is that that square root goes away. So if the square root goes away, remember what happens, if I can find it real quick. So if the square root went away, see how that the square root of 0 is 0? You ended up with how many solutions? One rational solution. So if the discriminant is 0, so since the discriminant is 0, we have one rational solution. We have one rational solution. Now remember, a rational number and an irrational number are real, so you may see one real solution as well. All right, one rational solution. Remember, it's also called a double root. So this is a double root. All right, so make sure you understand where that came from, that idea of that double root, because remember when we factored, remember this, if the discriminant is 0, it's factorable, and when we factor, the two factors are identical, so that means you ended up with 1/3 occurring twice, so hence the word double. Okay, so a double root or a double solution. All right, let's look at another one. So let's do number 3. Okay, so let's suppose we had x squared minus x plus 3 equals 0. All right, so again, you just want to find the discriminant to determine the number of solutions and what kind of solutions you'll end up with. So a is, first of all, it's in standard form, so that's important. And a, remember, is a coefficient of x squared, so that's 1. B is the coefficient of x, so that's negative 1. And c is your constant, and that's 3. And so when I use the discriminant, b squared minus 4ac, I'm going to get b squared, so that's negative 1 squared, in parentheses, minus 4 times a, which is 1, times c, which is 3. So I get negative 1 squared is 1, and this becomes minus 12, which is negative 11. All right, so notice the discriminant is negative. If it's negative, since the discriminant is negative, remember, that's not a real number. Since the discriminant is negative, we will have two different or distinct imaginary solutions. Imaginary solutions. You may also hear something like two different non-real complex solutions. All right, so you may see that. All right, so two different or two distinct non-real complex solutions just means that those are your solutions are not real numbers. So that means that they're going to be imaginary. All right, and so let's look at another one. So let's look at one more. Let's look at number 4. Okay, and so finally, let's do number 4. So notice that this quadratic equation is not in standard form. So let's go ahead and put it in standard form. So I'm going to get negative 2x squared minus 5x plus 12 equal 0. And so you could have brought the negative 2x to the other side. Does not matter. Okay, I want you to understand it does not matter at all. Okay, so a is the coefficient of x squared, which is negative 2. B is the coefficient of x, which is negative 5, and c is your constant, which is 12. And so I get b squared minus 4ac, that's a discriminant. So if I substitute these values into here, I get negative 5 squared, b squared, minus 4 times A is negative 2, times C, which is 12. So I get 25. A negative times a negative times a positive is a positive. And then I'm going to get 4 times 2 times 12, which is going to give me 96. And so 25 plus 96 gives me 121. All right, now 121 is a positive number. Y'all agree? So since it's positive, I'm going to ask you this. Since it's positive, am I going to get real solutions or imaginary? Real or imaginary? Well, they're going to be real, right? Because the only time you get imaginary is if your discriminant's negative. That's the only way you get imaginary. All right, now here's the other question I'm going to ask you. We know they're real. So since it's real, will it be rational or irrational? Well, what kind of number is 121? So you know it's going to be rational. You know you're going to get rational solutions if it's perfect square of 0. It's going to be irrational if it's not a perfect square. If it's a positive number, not a perfect square. So is this a perfect square? Yes, it is. So since the discriminant is positive and a perfect square, okay, we will have two distinct rational solutions. Two distinct rational solutions. Remember, rational number is also real, so you could also see, you definitely need to know that though, two distinct rational solutions, but remember, those are also real solutions. Also real solutions. All right? So a rational number and an irrational number are real numbers. All right, so just keep that in mind. Okay, so that was basically the idea of a discriminant. So it's important. It is important. I'm going to go ahead and decrease the size here. It's very important that you understand if the discriminant, b squared minus 4ac, is positive and is a perfect square, you're going to get two different rational solutions. If it's 0, you get one rational solution. If it's positive and not a perfect square, you get two irrational solutions. If it's negative, they're imaginary. Also keep in mind that they are real solutions if it's positive or 0. If it's negative, it's not a real number, though those are non-real solutions. All right, and I think you should be okay just by understanding this. You should be fine with the different types of situations you may have. So sometimes it may say rational, sometimes it may say real, sometimes it may say irrational, sometimes it may say real, sometimes it may say non-real, sometimes it will say imaginary. So just know if it's negative, these things. If it's a positive discriminant but not a perfect square, just know this. If it's 0, know this. If it's a perfect square and positive, know this. And you should be fine. Okay, so that'll be the end of this lesson.